Hey everyone, my name is Brett, and I am here to talk to you about how Google SREs like me modify production resources securely and safely. So by production here, I mean all of the software, the tech, the pipes, everything that works together to make a service work, like Gmail. So think the networking, like the actual cables, the switches, the virtual machine in Google Cloud or wherever, the tables in all of the databases that you use, all of that is production, the stuff that's running to make a service work. These things are changed all the time, such as if you push code that has to get deployed to that virtual machine. Or if you make an update to the database schema, you're making a change to something that's running in production. This presentation covers our approach for how we can safely make those changes. So I'm going to start with a quick intro of myself, the team that I work on, and the stakes involved with our work. And this talk is about 20 minutes long, and we have about an hour. So that means that there's a lot of room for back and forth, conversation. Chime in. If you're remote, post on chat. Kinsley will poke me to make sure that I answer questions really anytime. So I want this to be a back and forth. So before I begin, is there any question? Nice. Yeah. Oh, Kinsley. Yeah, great. Love that. Please post in the chat anytime you're not interrupting me. All right. So as I said, I'm a site reliability engineer or SRE at Google. SRE is a really interesting field that attracts people from a very diverse set of paths. For example, I didn't have a CS degree, came from Codesmith. I didn't even know what SRE was when I was applying to Google. So I wanted to describe a bit of like my path to SRE. I started out, I said academic research. Really, that means I got my master's. And so I was trying to figure out how to make more efficient solar cells. So I learned how to create and test hypotheses. Like I hypothesized that if we do a thinner layer of material here, it will create a more efficient solar cell. And then how do I write an experiment that proves that hypothesis true or false? Then my first job out of school was technical consulting or being a solutions engineer at a company in Long Beach, where I would go on site to some company that just bought our software and work with their users to figure out like, what are their problems and how can we like craft a spec and use the software they just bought to help solve those things. So that was a lot of like learning how to gather requirements and turn that into a spec. Then I wanted to be a software engineer, so I went to Codesmith, and there I learned how to actually write good code, especially the software engineering side of things, which is to me the like architecture of code and collaboration such that that code can live a long time past the person who wrote it actually writes the code. My first job out at Codesmith was at a startup, was doing med tech in LA. I joined when the company like raised a bunch of money and like 3x'd its employees in the span of a couple months. And so we were taking this like proof of concept that they built to get their first round of funding or second round of funding and turn it into a real product. So that was a lot of like, how do we make the front end scale to 10x engineers? How do we make the back end scale to 10x the number of users or 100x the number of users? And all of those things are all things that I do and use as an SRE at Google, specifically in privacy and security. So what does my team, privacy and security, do? We are a group of SREs, software engineers, staff, so that means like program managers and writers and stuff like that, that all work together to run the Google corporate and like the Google Cloud security infrastructure. There's a large overlap between security and reliability, since it's all about like making this thing available to a specific set of people to do the things that they're supposed to do. And that means that, when our services are unavailable, then at best, Googlers can't access their stuff because, our stuff's down, we close access to everyone, Googlers get the day off. But at worst, it means that there is a security incident. Before I move on, any questions? Just want to check in.
I have a question.
Yeah.
So Google says basically in its SRE recruitment that they're looking for people who have kind of a combination of software engineering skills and often like networking or Linux-based things. Was that sort of your experience working in the startup?
Definitely. I would say so at the startup, I was a software engineer, but what I realized was so close to SRE, which is why I ended up matching with an SRE team at Google, because it was a lot of, as we were scaling, figuring out how do we make a development environment that can support more than one person at a time. So that was a lot of building Docker containers and a CI/CD pipeline and all that stuff, which is very much the root of SRE. I didn't go through the SRE interview, which is a separate interview from the software engineer interview at Google. I just went through the software engineering one. So I just did the data structures and algorithms, but the SRE interview includes stuff like Linux fundamentals and troubleshooting and things like that.
Okay.
There's some graph that Google uses that is, there's an X dimension and a Y dimension, where the X dimension is the software engineering skills for hiring, and the Y is the systems engineer, or traditional ops and IT skills. And SRE doesn't require both of them to pass, but instead you can be just below the bar on both of them and you're still going to be an excellent SRE. So I think that's what they optimize for, is that the bit under the curve of both of those two things. Does that help?
Yes.
All right. A little bit about SRE. So this talk is framed within the scope of the core SRE mission, which is about how we apply software engineering approach to operating large Google scale systems. There are a lot of talks and books, including Google's original SRE book, that talk about the specifics of SRE. Highly recommend them. So I'm not going to go into too much of the details, but I do want to mention that when I say that we use software engineering principles, what that means is we're trying to have a service that scales exponentially, but the staff required to support that scales logarithmically. So that means we have to have, it's greater than linear growth, sublinear headcount growth. And the way that we do that is we look for improvements to operations in just like we would any other software problem. So we'll look at the context, gather requirements, we'll prioritize the benefits of doing some automation or some manual ops, and potentially implement it, and then look at it like any other launch and measure the success of it. The way that we implement those things is often, but not always, with code. So SRE, we really try to write a lot of code, even if that's not always what we end up doing every day. So, before I go on, any other questions about SRE as a concept? All right.
I guess, I don't know too much about SRE, so I'm wondering, how do you prioritize, an SRE feature or task or improvement being built?
Great question. So, we try to treat it like any other feature, where we look at the cost of doing it versus the benefit of doing it. And at Google, a lot of that means we can measure things if not in dollars, but in some analog of dollars. So a lot of what I do is look at the cost. This thing will take 3 engineering weeks to implement, and it will benefit us by saving X number of terabytes of RAM, because it's going to make something more efficient. And we have a mapping between 1 terabyte of RAM is worth this many software engineering hours. So if you would save some number of terabytes of RAM, it's worth spending some number of hours to build it. We have that direct map. So if you can do that math, then there's the decision made for you. But not everything maps that way. And so a big thing is like trying to sell a piece of work. Like, I want to work on this for 6 months. I need to go convince someone that it's useful. And that's a skill that I don't think I have expertise enough to, to answer. All right. So if SRE is about using software engineering to solve ops problems, why don't we just write software and automate every single process and eliminate the need for operations? Well, it's because we have a finite amount of time in the day. We can't build every single piece of automation that possibly could exist. And even if we did, we wouldn't know what to build. We can't account for everything that might possibly happen in production. An easy example of that is basically every outage in every incident. If there is an outage, it means that someone didn't anticipate a thing would happen and that thing broke and now we have to go deal with it. But we can need to touch production for just regular products or project work as well outside of an incident, and I'll get to that in the talk as well. The point is, eventually, humans are going to have to make a change to production somehow. So that gets to the core problem, which is human access to production opens reliability, meaning a human can make a mistake and cause an outage, privacy, so a human could see something that they shouldn't be able to, or security risk, meaning a compromised person could maliciously do something to production if their account is compromised. So how can we give these human SREs who introduce all those risks to access to production while minimizing those risks? And our general solution to that is to establish a prioritized list of methods for changing production, meaning we're going to have several different approaches for how we change production. And we want to start off with the one that has the least access to production, which is automation, full automation. No human needs to look at this. No human needs to touch it. It's fully autonomous. But if that's not possible, then we look at the next approach, which gives humans a little bit of access to production, a little bit of manual ways to touch something running that a human or that serves for Gmail. If that's not available, then we give humans a little more access to production. If that's not available, we give humans full access to production. But this should almost never happen because all the other things above should be picked first. I'm going to talk about these in detail, how they apply to incidents, how they apply to just day-to-day projects, along with a few examples and case studies from my team. I'll do another check-in.
We do have a question. I'm
Nice.
going to send out to you. What are some common tools and technologies that you use as a SRE?
Great question. The short answer is a lot of things that are built in-house, so the terms are not very familiar, but I can describe a lot of analogs. Like, we use, we have our own like continuous integration and continuous deployment pipelines. So similar to, GitHub has stuff like that, Jenkins, etc. We do a lot of things that are like called probers, or we call them probers, which are effectively little scripts that run once a minute or every 5 minutes. And what they do is they make a request like a user would to our service, and they expect a certain response back. So that could be something like we have a fake Gmail user, and a little prober will request to get all of its email. And it looks at the response and expects to see a bunch of email in there. And if it doesn't, then the probe fails. If the probe fails, then that's a good sign that something about Gmail is not working. It's effectively an integration test that we run continuously and gives us good data on like localized problems. And those local ones could be like this region is having a problem due to something about networking. It could be this build is having a problem, like the probes are failing for a certain build, but not for another. That's a good signal that that it's related to the build. And I know that AWS has an equivalent to this. I think it's called Canaries. I've used that before. There's a lot of things. I can help answer any specifics as well, but those are some of my favorites. Any others?
I think we're going to talk about this in a little bit, but have you been involved in any incidences where direct access was required?
Yes.
I'd be like curious to hear more about it, but you said you were going to have some examples, so if that's like a little further in, we can pin and move.
Yeah, I'll get there, and I'll save some stories for the end as well. But good question. So at that top of that list is the full automation case. So the vast majority of changes to production are done automatically by some script, some tool, some service, doing it without a human having to look at it, without a human having to touch it, without a human having to monitor it at all. And importantly, that means that this requires some sort of validation, some automated check that gives the humans confidence that the automation is doing its job. For example, that continuous deployment pipeline. That is something where it will take a build, a bunch of code that's all bundled up, and push it to all of the virtual machines around the world to update them so that they're running new code. That happens on a schedule. Maybe it's daily, maybe it's weekly, maybe it's every 15 minutes. But a human only can safely ignore it if they have faith that it is doing its job. And that means that we have monitoring in place that checks to make sure each of those virtual machines has a build that is less than some amount of time old. So if let's say we update weekly, we'll have an alert that says if after 10 days we haven't received an update, that means that something's wrong with the pipeline. And only at that point, a human needs to go and look at the pipeline. Another example for like incident response is load balancing and denial of service mitigation, where there might be some spike of traffic that is taking down a server in one location, and that load balancing or can just shed the load either to a less busy location around the world, or get rid of it altogether and just decline to respond. Like Google recently survived the biggest DDoS outage thanks to this type of automation that just can identify, this looks bad, let's shed the load without a human having to get involved. I'll check in for questions while I take a sip. Thanks. Case study. So this is something that our team did specifically to implement this. So our team runs a bunch of services. Those services run on physical hardware. So a machine running in a data center somewhere. And those machines are replaced periodically, either because they break and they need to be repaired, or they get upgraded because new, more recent stuff comes out. When we get new machines, we also get new IP addresses associated with those machines. And those IP addresses need to be trusted in the software-defined networking stack at Google in order for the network to trust them and send production traffic to them. This requires adding new networking rules or like firewall rules to that software-defined networking. And while a lot of hardware is manual because you have to physically plug in and unplug stuff, our team doesn't deal with that. So we wanted to prevent remove this error-prone, toilsome task of every time we get a new machine having to go update an IP somewhere in some location. So our solution was to build automation. This is a perfect candidate for automation, where we built a script that runs periodically, and it looks at all of the IP addresses for all of the machines in our fleet, and updates the firewall rules to contain those IP addresses. That means that, it adds a little bit of time because this automation might run daily, might take a little time for all the stuff to propagate, and that's time where that machine isn't doing anything. It's just sitting there idly. But that trade-off is well worth it because no human has to be involved in the process anymore. We don't have to worry about typing in the numbers wrong. We just wrote a little script that does it all for us. This is when I think of like the archetypical like SRE thing. It's, hey, this operation is annoying. I'm tired of clicking this button. I'm tired of typing this thing in a file. I'll just write some automation that'll do it for me. And that's exactly what we did here.
When you were pitching this, do you know how much like dollars it costs a RAM that you were talking about earlier?
For this, thinking about it in like the frame of like everything comes down to like software engineer hours, and it's probably like, I didn't actually implement this, but I imagine we did the math and it was like, we have to do this probably once every month. It takes us a couple hours every month. I could spend 2 hours to write the script. Therefore, over a 2-year life cycle, I'm saving, 50 hours for 2 hours of work. So that's the kind of cost benefit analysis we might do.
Okay, cool.
I think there's also probably like harder to quantify benefits of like, and if someone made a mistake, then it might mean this bad thing happens, and that has this other cost, but it's a low probability. So depending on how much you want to sell something, you can like, I love going and doing that math. Like there's a 10% chance of this outage. The last time this outage happened, it cost us, I don't know, ads are a really easy thing to point to where it might be $100,000 per some period of time. So last outage cost us this much money. Therefore, I am statistically saving us 10% times that amount of money. It's an easy way to justify doing some stuff. All right. So back at the start, I said that we can't automate everything. Even though the vast majority of things are automated, we still have to eventually have a human push a button and do something. And in these cases, we try to make sure that almost all of them are done by the next thing in that prioritized list, which is a tool-guided manual intervention. So in this case, think back to that continuous integration, continuous deployment pipeline, a human clicking the rollback button or the rollout button. The human's not actually, SSHing into a virtual machine. A human's not bundling anything. They are instead interacting with a tool that has the privilege to do it on their behalf. The downside of this is it's still toil. A human has to think about like, what am I supposed to be doing here? Maybe they were interrupted from something. If it happens all the time, then they might never be able to get any other work done, even if all they're doing is clicking a button. So we really try to avoid this when possible. And that means that there are sort of two cases where we need to do this. One is like the automation doesn't exist yet. So in this case, you could imagine like there isn't a way to fully automate some process. In that case, we'll file a bug or file a feature request saying, let's add a feature so that way we build automation to automate this thing. And therefore I don't have to click the button anymore. That was sort of what I was describing for the IP address automation there. Or this might happen when something in the automation failed. So let's say that CI/CD pipeline missed a bug and users were affected, and you have to manually trigger a rollback. That's a human going into some dashboard somewhere and clicking the rollback button and watching it and making sure that it completes. Toilsome, it's slow. Maybe you click the wrong button because you rolled back the wrong thing. You never want the human to have to get involved there. In that case, we file a bug saying, hey, our test suite missed this bug. Let's add that use case to the test suite so that way we never miss it again. But sometimes building good automation requires like taking a step back and looking at all those feature requests, all those bugs that have been filed, which happen all the time, and seeing some generalized pattern. So let's say, I filed a bug this week because some some users were broken. I had to roll back a release. And, the same thing happened like 2 weeks ago. And the same thing happened 6 months ago. I could take a step back and see like, oh, maybe I can solve the general case, which is automatic rollbacks if a certain number of users report problems, or automatic rollbacks if, some of these probes that I'm describing have an error rate that passes the threshold. Now I'm building automation that like solves a bigger case than the specific bug that I filed.
Do you guys do like timed rollouts, like percentage rollouts? And if so, like this kind of tool guided manual intervention, like if you roll out to, I don't know, 5% of users, you would still have that like within that percentage, that kind of thing. Like if certain numbers.
Absolutely.
In there.
Yeah. So like we have different rollout strategies based on what we're trying to roll out. Like some things we might be really risky and we'll do like a super slow rollout where it hits, like 1%, then 3% and so on. Some things we are pretty confident in and will just hit everyone in the span of a couple minutes. But yeah, we definitely like look at that 3% and say, how are those 3% of users doing? And if they're having a bad time, that's a very good reason to roll back. Or like if someone actually comes to us and says, hey, I'm having a problem, we'll see, like one of the first things we ask is like, are you like, well, maybe they don't know the answer, but we try to figure out, are they in the pool of users that are in that 3%? Or are they in the 97%? Because if they're in the 3%, that's a very good sign that we should just click that rollback button. And we are very quick with the rollback trigger. It's much easier to roll back code than to try to troubleshoot something. Good question. Yeah. All right, back to our team in specific. So this case study highlights how we might decide not to automate something and instead deliberately use a tool-guided manual process. So we have, a bunch of tests in our deployment suite that regularly, autonomously test our critical user journeys, which are the set of features that together form what a user would have to do in order to do something that they want to do. So you can imagine for Gmail, like that would include opening up their inbox, clicking on an email, and maybe hitting the reply button and sending it. That's one critical user journey. So we have tests that simulate those. And if those work, that's generally a good sign that the product works before we push a release out. So those tests are the gatekeepers that we run before every release. However, for one of our services, one of those critical user journeys involves pushing a physical button, such as a security key, like a YubiKey that you might have. And, we can't write a script that pushes a button. Well, not without like a robot, I guess, with like a little sausage finger. So our solution is to automate everything else. Every other critical user journey is automated. So a human doesn't have to think about them at all until they fail. Then for the one button pressing case, we have a human go test it themselves with a guided script where all they have to do is they have to click enter to start the script, and then they touch their security key. That's it. It takes 1 minute. And we attach here an SLO, meaning a service level objective. Basically, we say, you got to do it within a couple hours of it being assigned to you just to keep the schedule on task without rushing them. And, a fully automated solution would involve building like a virtual interface where, it thinks that it's getting touched, but that might not actually simulate the full experience of touching it. So, we could build something that does it. But ultimately, we determined that the cost of 1 minute per week to push that button was not worth, the cost of doing that every week, which is the manual operation, is small enough that the spending the time to automate it, to build that virtual interface, is just not worth it. It would take us days, weeks, maybe months to build that. And we would just never get a return on that investment. So in this case, we just made it as easy as possible. It takes 1 minute. but it's still manual. Before I move on, I'm going to check in. Yes. Toil. Yeah, we use the word toil a lot at Google.
So like interviewing at Google, you should just like drop your friends, right?
If you're interviewing for SRE, if you talk about how much like you're just passionate about removing toil, people are gonna be like, not a joke. All right. The third of the 4 options is if the manually controlled tools aren't capable of making the change, then we use that next thing in the prioritized list where humans can make individual peer-reviewed changes. So you imagine like if you want to make a change to some VM, like you want to restart some VM, you can do like SSH, blah, 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 restart. And that's one action that you're telling production to go do. If you had access to that VM, you could just go do that. But we don't actually have ambient access to production. We can't unilaterally run that command. Instead, we have this system that we built where an SRE will send to some third party, meaning probably just their coworker, a command that says, I want to go restart this VM. And that person will look at the context. Maybe they see a bug associated with it, a little bit of text saying, you know, this thing keeps restarting, or every request to it fails and I don't know why, so I'm going to restart it. And that second person will say, looks good, give them the stamp of approval, and then our tool will go run that command for them. So the human isn't the actual one who's sending the restart command. Instead, it's this tool that is executing it by proxy. So rather than, it's effectively like on the command line, instead of saying restart, I'm saying use this proxy to restart. And then it goes and sends the request to one of my coworkers. And if that coworker does not approve it, I cannot do that request. It just denies me from doing it. And this removes my unilateral access to production. Everything has to go through 2 people. That said, this should happen very rarely, and only when there isn't a good tool or process to do something, or that tool is down for some reason. Like you can imagine if the UI for interacting with your deployment pipeline is down, you're probably going to have to run a command that goes and tells the VM to go update itself. Either way, like that's a bug. That's a thing that probably should be prioritized to go fix. This should not be part of the day-to-day process of doing things. As a result of that, using these peer-reviewed changes is generally reserved only for incident response for us. Like if you're doing this every day, that's a lot of work for you. It shows that there's a hole in our automation, and you're probably bugging all of your coworkers. So it's a good sign that this is something that we need to go prioritize. For a case study, checking in. All right. Back to our team. So this case study is one of those times where we decided that building the tool or automation altogether isn't even worth the benefit yet. Actually, since I wrote this, we might be changing our mind here. So like many teams at Google, we have credentials and secrets that we need to rotate periodically. So you can imagine some signing key that encrypts some piece of data. That thing needs to be rotated so that way if it ever leaks, then it can't be used anymore because you've rotated it and it's no longer trusted. Also, like many teams, we automate every single key that we can. We automate the rotation of every single key that we can. And Google has tools that we built internally that just off the shelf, you say, hey, I want a key and I want you to rotate it every month for me. And the tool will just do it. But our team uniquely sits at this weird intersection. I said, like, you know, we do security stuff for corp and cloud. These things like generally mean that we are a snowflake at Google, and a lot of the like off-the-shelf solutions don't really work for us. And therefore, there isn't a good solution, a good generic solution to do a key rotation for some of our keys. Therefore, we decided that we'll just rotate them manually every year. The rotation takes a couple of hours to go, you know, run the commands. We do that once a year. And in comparison, to build something that automates it would cost us probably like a month of time. So instead, you know, like if I get the task that says you need to perform the key rotation this year, I'm like, darn, there goes my day. And I'll write the command. I'll get that second party approval from one of my coworkers. Then I'll write the next command, get the approval. Then I'll write the next command, and just do that for the rest of the day. It's a pain, but it's worth it to spend that one day to rotate this key versus the allotted amount of time to automate it. We are potentially changing this. I think we actually are going to automate it after all, but that doesn't make as good of a story. All right, the last and final option. If all else fails, an SRE can directly modify production using emergency credentials or emergency processes. So this should be incredibly rare and only happen if all of these things occur. One, there's an incident that requires immediate response. This should never be done for anything that's non-emergency. No bugs, no project work, only emergencies. Two, there isn't a tool that exists that already does this for us, or, you know, perhaps that tool isn't available. And three, the second party approval system is not available, because if it was available, then I would go through that previous option where I get my coworker to stamp my change. And last, but certainly not least, I am someone who should be able to do this at all. Like, just because I'm an SRE doesn't mean I can go break glass and make a change to Gmail stuff. I can only do it to the things that I own. There is a non-zero chance of all of those things happening. We need to make sure that there isn't some correlated outage that takes down, you know, that two-factor step and takes down my release pipeline and takes down whatever else. It's definitely possible. And we don't want to lock the keys in the car by preventing an SRE from being able to just break their way in and make the change. You can think of, you know, perhaps there was a major outage at a large social media company, I think last year, where it was down for like an entire day, and allegedly a human had to go to a data center and use bolt cutters in order to get into some machine and make the change. We want to prevent that from happening. And that means keeping pathways like this open. I don't have a case study for this because I don't think I've ever used it. And that said, the closest thing to a case study is that we do practice it periodically, just to make sure that, like, if there is an emergency, like, it's not weird. Like, we know how to do it. So all of the things that I've described have been a long time in the works. Like, I've been at Google for a little over 4 years. This has been a big thing that I've worked on, is trying to set up this process. And we've come a long way from when I joined. Our team started enforcing this policy at the beginning of 2022. And since then, we've dropped the access to production by 80%, which is pretty huge. And we removed the ability for people to ambiently, meaning like they can just go and make a change without another person approving, to 0. We've never used it, and you can't do it without going through that break glass process that I described. For our team, like, we still have, you know, more to go. This is a continuous process of improvement. So some things that we're working on still is we want to improve our tool coverage. So that means we want to move more production changes up that list towards full automation. Maybe that means taking that manual key rotation and bumping it up to something where it's tool guided, where all I have to do is click a button in an interface. Or maybe moving something that's, clicking a button into an interface and write a script so nobody has to click that button. And improving tool reliability, because a lot of the times that I can't do the full automation is when something breaks. Our release pipeline breaks, I have to go touch something. Ugh, pain. So let's make our release pipeline more resilient, and therefore I don't have to step in. So in summary, we modify production in these 4 broad ways. First, most changes use automation. Second, a few are human-led through guided tools. Third, tiny fraction are when a human has to run a command that's approved by a second party. And last is, in emergencies only, we have a process for bypassing everything and making a change to production directly. So I think the key here is that SRE is still software engineering practice. We use software engineering principles to decide how to prioritize, how to make those trade-offs of what's worth the automation, what's not, and iteratively work towards, even if we never fully reach a world where 0 humans ever touch production. Thank you.